it will just sprinkle. So as long as it is wet, there is no dust. When it becomes dry, again there is a dust. So why it is happening? That means if you can keep it wet, then no dust problem. So everywhere we know, when there is in front of house also we sprayed water. We have to make it wet so that there is no dust problem. So we try to put a layer of those biopolymers. Daytime we keep it outside. These are very small tests. Okay? Daytime we put it outside, evening we bring it back. Again daytime, these were 7 days. And another without this one. And 7 days, every day we take its moisture content and how it is varying. If we have got such a cover, the loss in moisture content is less. So moisture content less means it becomes, as I said, it is wet. That is maybe apparent question, but it is stable. It will not fly. For that, laboratory we have got a wind tunnel, 100 km per hour. That is the type of speed we gave in that wind tunnel to see how much is the loss, how much is the erosion. So based on that, we saw that, actually the diagram, it is somewhere misplaced, this one. So we try to get how much is the loss, weight loss. When it was without, there are lots of weight loss, and with polymer, biopolymer, hardly any loss. But how many can afford this wind tunnel? So that's why we tried for another test which is called penetration test. These are very simple tests. In your that severe test mold or test setup or even your UCS, 6 mm diameter cylinder, we try to penetrate. Just see the difference of it. What is the difference you are seeing? Around this so many cracks, and in this you see no cracks. This is with biopolymer, this is without biopolymer. So once the crack starts, so that means then that is vulnerable for the erosion. So this way we try to correlate this penetration force. These are the different values you see. These are with, these are without. This is another one. As I said, coal mine area. One was the fly ash, other was that mine overburden. They call it as a mostly cell, black cell. So these two, I try to do it and correlate with this one, maximum penetration force that I can measure. But I did some test only with the wind tunnel and I got a correlation. Similar correlation can be developed for different materials, and I don't go all the time for the wind tunnel test. So this proposal I was using, as I said, Jantham gum, guar gum. Then they said from one place, they say Maharashtra, guar, I mean most of you know guar that beans. They say it has some problem with the groundwater. But I said this is only surface and spreading. I am not putting in the ground. And it is also getting dried off within 15 days. I have trained with 2-3 cycles, around 21 days. So then it dried up. But you just imagine, by providing one coat for 21 days, you are not sprinkling water after 2 hours. This is a problem in many mining areas. They are using some of the other materials because this has to be sustainable. And these biopolymers are not that problem, except Jantham gum, people use it in the cake. So obviously it is not hazardous, I mean that dangerous. And the guar gum only, there is some problem, but because it is a surface phenomena, it is not that difficult. That is one. Then another one, look at this diagram. Here what I was saying, when it is wet, it was creating problem. For that, there are one called ASTM standard dispersion or pinhole test. So in the pinhole test, we have fabricated in our laboratory small, within, I mean maybe 500 or 600 rupees. So you see such materials, that material, not all materials, if we put the water through it, there will be the dispersion. That is a property called dispersion. Soil will disperse. It will pass through it. You might have heard about expansive. soil. As a civil engineer, we call it black cotton soil. So it's just opposite to that. Expanding soil expands, and in dispersion soil, if it dispersive soil, the volume in water will decrease, not increase. Just opposite. And that type of soil also, because one professional engineer, he said, in my 35 years of experience, I have never faced this difficulty. And this problem came, you see, why civil engineer is the advantage, if you get exposed to the field, you have all these difficulties and problems. In our own campus, it was a waterlogged area, we went for pile foundation. The consultant, he said, the pile capacity of 35 ton. And around 200 piles were there. But when you test the pile, it came only 22 ton. 35 to 22 means we have to increase number of piles. Why it went wrong? Because as per the Indian standard IS 2911, everything was fine. So I talked to one geologist. He said it's a residual type of soil, red soil, the top residual soil said top red, and slowly as you go deeper, you will get that whitish alumina silica, because red, iron and other things, so they sit in the top, that's why it looks red, and as you go down, alumina and silica, they are light color, that will be white. And that was there, and it has got hardly any strength. So that's why if you want to use the pile there, continuous drill mud pump pile you have to use it, otherwise go for raft. So that is how I came to know what is a dispersion soil. I never read in my BTech, MTech, PhD, nowhere I read about that dispersive soil. I asked to one of the professional engineers from IIT Madras, he is in Madras, he was my senior at IIT Kanpur. So he said, in western coast you will get lots of things, such soil. And in another, just after that I came to one conference at Goa. So there was a landslide. One of my another senior is a professor and head at National Institute of Disaster Management. He was asked by government of Goa to investigate it. And in one, fortunately I was with him. So just I explain, you see, this is a tough hard soil. In between there is a soft soil, that whitish soil. So once the water, rainwater passes through that, it simply becomes like a sliding, that your cake. You have got different layers, a soft layer. So that soft layer slides. And through that, they could actually, it was found exactly at that depth, that layer is there. So that also helped me to go for another, there was a big thermal power project in Chhattisgarh. It was more than 1,000 acres. And they had done lots of investigation. But I was only searching for that problem, because whenever I found residual soil, I tried to find out where is that culprit. It has to be there. If it is very deep, maybe 30-40 meters, it is not going to create problem. And there also they are putting that boiler, and it is too very heavy, and they have to get very good foundation. It was almost this season raining. Their vice president was there. I went there for a day only, just for a visit. So they said, just come and give just your suggestion there. I said, no, it is possible, you excavate more. Another 2 meter excavation, we got that one. That is only 1 meter depth, not more. It may be 1 or 2 meter depth, but it's locked just like a chalk powder, hardly any strength. So the vice president in front of, because he was there fortunately, he saw it. He gave the instruction, anywhere forget about all the testing. If you get this soil, just excavate it out and put my foundation. So that is how I came to know about dispersion soil. And that I tried to put in such cases, this was the training. So when I came this problem, I did that testing. So I explained them that you see, this fly ash is dispersive. It cannot bind them together. So if you have got, you can test it. So but if you can use some, this is all academic exercise. Now I am saying, using biopolymer, I could prevent that. But how it is vulnerable at the site, that is an issue. But this you see, I tried for, this is also possible. That means water erosion also can be prevented using this biopolymer. So quickly, these are the different tests I'll go for. This is another called cylindrical test. You see, that white soil, what I was saying, actually, if you put it, make a cylinder, put it in the water, it will immediately dissolve. Ordinary what that you are making that UCS samples, those civil engineering basic also, you put in the water, immediately not dissolve, but this will immediately dissolve. So that way, if you have got something, you can prevent it. How much time I have got? Or it is already time? 5 minutes. I will try to wind up. Sorry. So these are the microstructure analysis why it is binding. I will come to another problem which this red mode. So I am trying to tell you where is the problem and how you can start it with. Because there are two types of research. Either you are going for basic research or applied research. Basic research, I say, even when I graduated, my professor said, if you are in IIT, then you try, otherwise don't venture. If you are in NIT, you may difficult to do basic research because that much of infrastructure you might not have. As I said, 2 SCM that time, those days. So it was easy. But applied research, I can think of looking at the site and fabricating little bit of rudimentary experiments, I can do it. So this is what happened, and this is a place from where we collect the red mud. That is in Tamanjodi, Nalco. These are the, what you say, after the raincoats, these are the channels. So this says that these are dispersive. So this is a basic property, I am not going for that. This again we tried dispersion test. This is another type of dispersion to check dispersion. We make a hole through it and check whether the hole diameter is increasing or decreasing. They vary because you see dispersive solve, that's why I have got, many people are not appreciating the word the dispersion. Many industrial waste have got these properties, that's why I said red mud, fly ash, these properties also need to be studied. So then, this is a test. In your jar, 1000 ml jar, we put a paper scale. This is a paper only, paste on that. And what we measured? We measured how this is settling down. And that sedimentation has got flocculation, settling. This is or not sedimentary consolidation zone. These are 3 types of zone. And you see, when ordinary red mud, there was a long flocculation zone. It was just floating like things. It was not settling down. Then after, it was settling zone and other zone. What we did to accelerate, we poured some called phosphogypsum, sodium chloride. There is no flocculation zone, settling zone, and immediately it getting settled. Why? Why you did this? We try to see the microstructure. They are covering it, so that's why it is getting settled. There is one term called zeta potential. So while doing very common things, try to find out, pick some scientific word. So then other academic community will be interested. If I simply said that I did put this one, measure this ordinary one, nobody will appreciate. So I measured another property called zeta potential. So based on this zeta potential, I try to explain it. So then academic people will be interested. Otherwise will say, oh, by chance you did something that is not appreciable. So zeta potential says, in this zone, that pH will be here, and then that is the zone where there will be good settlement. Why? Because when this ASCA failed, red mud is not getting settled. So it is in suspension. We traveled a very long distance, making havoc in many areas. So for that, a simple test. This is the mold we prepared. There is red mud slurry without anything, how it is spreading, and with it how it is spreading. Just we explain this one. This also now it is published one of the ASC journal. It is not yet to come. These are the experiments, nothing else. Okay. So we said this is a probable that you can manage it. You can make it sustainable in the sense even if it also fails, it will not spread to a large area. So that way, sometimes you have to find out certain things and do some of research. So this is another one, geopolymer. I am not coming to it, but I am only coming some of the things like you have to, for those who are working on alkali activated material, some of the things I find like this. Whitish in red mud. You see this patch, how you manage. I am not trying to explain it here. Another one, I have not presented any test which is not possible in any engineering college. We can, this is only here because we may not go very fundamental, but we try to make an eye opener. These are the issues should be, taken care of. So here we put it in a jali, you see, very stainless steel jali as one of it, and only we spend around 12,000 rupees for a DC volt, constant volt, 30 volt for that, and we found these are type of the corrosion. This is another type. It was not part of the research, means it was just like to see. As I said, I was also involved in construction when you are going for some new materials, and so like some people come, my aggregate is good, whether it is a the granite aggregate or maybe with limestone aggregate, I simply put in the acid and check it. Because sometimes you have to explain them with a proper evidence that you see your material is aggregate is good or bad. Otherwise they will say go for 100 tests, but you cannot wait for so long. So similarly here I try to say that if you are doing such cases, look at the corrosion. You try to explain. I am not going to this as a printing in a, publishing in a paper. But as I said, some of the tests we have conducted just to know what happens here. You see, here these are the, what you will say, this is the corrosion, and why it is nothing there. This is another like material. Some cases we are finding such type of corrosion, but here we are not getting it. So these are all industrial waste. Here I am saying red mud. Here it is another ferrochrome slag, what I said you. So this is the starting only. We have not done in test because that's not our domain, but we said when we are saying, because we are supposed to, as a control low strength material, to do a test, we take 90 days. After 90 days you can do it, but we don't, because students sometimes has a restriction of you has to complete and go. So that's why I did an oxalated corrosion. So I say you do it if it is possible. So these are the types of things we got it. This is another durability. As I was saying, strength was fine, but there is no durable. This is alternate wet wet and dry cycle. These are all durable. Okay. Okay, now I have finished. I don't have to take more time. But these are the challenges. When I said I don't have a equipment, this mine overburden, if I want to make it aggregate, because mine overburdens are big size. I want to use it, my civil construction means I have to make it small size. I put it in my crusher, which is general laboratory crusher in the metallurgy department, it made into powder. Because that is for hard granite and this is cell. So obviously you will grind it. So I need something. So I told to one of my BTech student, can you do something? He has made this in ANSYS only, not yet come to the light. So to get it, that can you have such a blade so that it will do only for the soft rocks? Because our things is there for hard granite, that crossing machine. So you have to have a different crossing machine. Control western material, I said, we have to mix it. Will it be like a concrete drum mixer or some other mixer? Because concrete drum mixer, there is nothing. Because I am saying soil. From the side it will be, you have to scrap it. Otherwise it will fix to the side also. So that's why this we have fabricated. So that way, and we have got fabric, this, if you see this container, this was a big AC pipe, because I am in the construction, so everything is it. So a big AC pipe was there, I cut it into the size and used that as a container, I mean that drum barrel. So and then with a steel inside that shaft with a motor below, I try to rotate it. So this way, I mean, these are all the challenges. And side there is a, you see, there is a place from through which you can take the sample out. So I will say that's what I started with. Ignorance about industrial waste make it as a waste, but knowledge about this will make them as wealth. So we have to use this industrial waste to save the Mother Earth. So that's why we are saying sustainability. Everywhere now we are talking about sustainability. It should be coherent sustainably. So that's why in GIST I try to say different industrial and mining waste and what are the techniques we can use to convert it to a natural resources. Thank you very much. If anybody has some queries. Yes, please. Yes. Yes, yes. And is xanthan gum, cellulose, methyl, salt. So CMC we found because initially we use xanthan gum and guar gum. No, that's what I said, because when we are taking help of life science, that time we are we are using that. Now even where to make this bacteria survive, we are taking the from the hostel, that rice, after the rice, what they call it is, after the boiled rice, that water, we are trying to use it, starch. So that was also you are using to make them survive. But as I said, the amount of biopolymer coming out of it is very less. When I go for physical properties are not possible, so I try to use direct biopolymers. Otherwise from that. Okay. Okay.
It is purely to him.
No, actually to others maybe no. Please give me so the others should also.
You said like some bacteria you can use it for some culturing or so in the red
yes,
mud.
actually try to put the bacteria, NICM bacteria, that is Xanthanum campestris, and other was some starting with a D. Actually the name is
currently we use this red mud only on